One of the main mechanisms we think that drives eruptions is buoyancy, and that is when for many materials, the liquid is less dense than the solid. And that's one of the main factors in buoyancy. If you have a liquid and a solid, usually the liquid will float to the top and the solid will float to the bottom, and water is one notable exception. You all know that ice cubes float on water. That's because ice is a rare thing where the solid expands more, so it's a little bit less dense than the water and it floats. But lava is one of the regular ones, where the liquid is less dense than the solid. So in our hotspot, we have some material that is more liquid than the stuff that's around it, therefore it's more buoyant. And the liquid is being forced up to the surface through the oceanic crust. And it actually, the buoyancy forces it almost to the surface here. Buoyancy is actually a very strong force under volcanism. It's not the only one, but it's one of the major ones. You can see the different states of matter and their effect if you watch a lava flow, an active lava flow. A lava flow comes out of the ground, mostly liquid, and it's very hot. It's about 1150 degrees centigrade here in Hawaii, which is about 2100 degrees Fahrenheit, or maybe about 1/5 or 1/6 of the temperature of the sun. It comes out molten because it's so hot, and it flows over the ground, but we all know that the lava flows stop at some point, or they slow down. And one of the reasons they slow down is because that liquid is changing the state of its matter from a liquid to a solid. It starts out changing right at the surface where the liquid is in contact with the air can transfer heat away from the liquid. As the liquid loses heat, it becomes solid. And it goes through stages of being like a gel first, and then like a plastic, and then like a solid. If you watch a Buoyancy flow very closely, the skin actually forms over the Buoyancy flow, and then it blows up like a balloon inside that skin, and the inside is still liquid, but it's slowly cooling off. The lava flow will completely stop when the whole thing, or most of it, converts to the solid by losing enough heat. If forces are in balance, nothing happens. It takes a force to be out of balance for action to occur. And in this case, if it wasn't for the buoyancy of magma, we wouldn't have volcanoes here. And it's of course why we don't have volcanoes elsewhere, is because there's no magma there to be buoyant to force its way to the surface. One of the reasons that belief in Pele has persisted amongst Hawaiians in particular is because when you're here, you feel the presence of something. It's a very special place. You see real unusual phenomena, almost supernatural phenomena, in flowing lava and in watching eruptions happen. Sometimes as a scientist, it's almost difficult to concentrate on the scientific aspects and just observe, as you experience so much. But I think that's one of the things that Hawaiian scientists can bring to science, is maybe a little bit deeper understanding of some of the local phenomena.